Next is question number 66, which says that if fx is equal to integral e raised to the power ax into sine bx into dx and f of 0 is equal to minus b upon a square plus b square, then one of the values of x, if fx vanishes, means we have to put fx equal to 0. Now, firstly, we have to find the integral, which will be equal to, we know the direct formula for this, that is e raised to the power ax upon a square plus b square into a into sine bx minus b into cos bx. We know the direct formula for this integral. Either you can directly write it or the integral can be solved by applying by parts 2 times, right? Now here a constant of integration should also be applied, right? Now f of 0 have been given, that is I have to put x equal to 0. So at x equal to 0, f of 0 is equal to minus b upon a square plus b square, and this will be equal to e raised to the power 0, that is 1 upon a square plus b square into, here it will be 0 and here it will be minus b plus constant, that is the value of constant is equal to 0, right? So we can say that this tends to 0. Now we have to find the value of fx vanishes. Now let's put fx equal to 0. So this is equal to 0 is equal to e raised to the power ax upon a square plus b square into a into sine bx minus b into cos bx. Now this term can never be 0, so we can say that this term is equal to 0, that is a into sine bx is equal to b into cos bx. That is the value of tan bx is equal to b upon a. Hence we can say that the value of x is equal to 1 by b into tan inverse b by a. That is, the correct answer will be option number 4. Next is question number 67, which says that the area of the region bounded by the curve y equal to sine inverse x and the lines y equal to x, x equal to 1 is, let us plot x and y axis, and let us say this is the graph of sine inverse x. And this is the graph of y equal to x. Now, we have to find the area bounded by y equal to sine inverse x and the lines y equal to x and x equal to 1. So, let us plot the line x equal to 1 as well. Let us say this is x equal to 1. So, we have to find this area. Now, this line is y equal to pi by 2, right? That is, this point is 0 comma pi by 2 and this point is 1 comma 0. Now, to find this area, let us say these points are O, A, B and C. Now, to find the required area, let us firstly find the area of the rectangle OABC and subtract area A1 and A2 from here, right? Now, the required area A is equal to, area of rectangle will be equal to pi by 2 minus A1 minus A2. Now, A2 is simply area of a triangle, that is half into base is 1 and this point is also 1 comma 1. So, A2 is equal to half. Now, we have to find the area A1. That is, area A1 can be simply found by finding the area of sin x from x equal to 0 to pi by 2. That is this area, right? And we know that this area is equal to 1. So, we can say that area A1 is equal to 1. Hence, directly area A can be found as pi by 2 minus half minus 1. That is equal to pi by 2 minus 3 by 2. That is equal to pi minus 3 upon 2 square units. That is, correct answer is given in option number 2. Next is question number 68, which says that solution of the differential equation dy upon dx equal to cos x minus tan y into cos square y is. The equation can be rewritten as secant square y into dy by dx plus tan y is equal to cos x. Now, the equation is of the form linear differential equation. If I put tan y equal to t, that will give me secant square y into dy upon dx equal to dt upon dx. Now substituting this in the given equation, we will get dt upon dx plus t equal to cos x. Now the equation have become very simple, where the value of p is equal to 1 and q is equal to cos x. Hence the value of integrating factor is equal to e raised to the power integration of 1 into dx, that is equal to e raised to the power x. So the solution of the given differential equation is t into integrating factor is equal to integration of e raised to the power x into cos x into dx. That will be equal to e raised to the power x upon 2 into cos x plus sin x. This can be found by applying by parts 2 times, right? So this is equal to value of t is equal to tan y into e raised to the power x. So the solution can be written as 2 into tan y is equal to cos x plus sin x plus any constant c dash into e raised to the power minus x. That is, the correct answer will be option number 1. Next is question number 69, which says that number of points of non-differentiability of the function fx equal to mod x minus half plus greatest integer of x, where x goes from 0 to 4 is. We have to find the number of points of non-differentiability. Now, we know that the given function fx will be equal to half minus x plus greatest integer of x when x will belong from 0 to half, and it will be equal to x minus half plus greatest integer of x when x will belong from 1 by 2 4. Right? Now we have to break the interval at 1, 2 and 3. So we can say that fx will be equal to, when x goes from 0 to half, greatest integer of x will be equal to 0. So this will be half minus x. And when x goes from half to 1, then also greatest integer of x will be 0. So it will be x minus half. And when x will belong from 1 to 2, then its value will be x minus 1 by 2 plus 1, that is x plus 1 by 2. And when x will belong from 2 to 3, then its value will be x plus 3 by 2. Similarly, for x going from 3 to 4, its value will be x plus 5 by 2. So this is the function fx. Now to find the points of non-differentiability, the continuity of the function should also be checked. Let us find at x equal to half. We can see that the function is continuous here, and at x equal to 1 it is not continuous. X equal to 2 it is also not continuous, and similarly at x equal to 3 also the function is not continuous. Hence we can say that at x equal to 1, 2 and 3 the function will be non-differentiable. Now let's check differentiability at x equal to half. LHD for x equal to half will be minus 1 and right hand derivative will be 1, which are not equal. We can say that the points of non-differentiability are 1 by 2, 1, 2 and 3. Hence we have 4 such points. Therefore the correct answer is option number 1. Next is question number 70, which says that if sin theta, sin 2 theta, sin 3 theta are in AP, then cos theta by 2 cannot be equal to. Now we know that for 3 numbers to be in AP, 2 times sin 2 theta will be equal to sin theta plus sin 3 theta. Now this is equal to sin c plus sin d is equal to 2 into sin of c plus d by 2 into cos of c minus d by 2. That is theta. This is equal to 2 into sin 2 theta. Taking 2 into sin 2 theta, taking common, it can be written as sin 2 theta is equal to 0 or cos theta is equal to 1. Now from here we will get that either cos theta is equal to 0 or sin theta is equal to 0 or cos theta is equal to 1. Now these are the 3 possibilities that we get. Now we have to find cos theta by 2. Now this can be written equal to 2 into cos square theta by 2 minus 1, that is equal to 1. So from here we get that cos theta by 2 is equal to plus minus 1 by root 2. and from here we get 2 into sine theta by 2 into cos theta by 2 is equal to 0. That is again either cos theta by 2 is equal to 0 or sine theta by 2 is equal to 0 means that cos theta by 2 is equal to plus minus 1. And from here we get 2 into cos square theta by 2 is equal to 2. That is cos square theta by 2 is equal to 1. So from here also we get cos theta by 2 is equal to plus minus 1. So from the given options that we can see that it can take value 1 by root 2, it can take value 1 and it can take value 0. Root 3 by 2 is the only value from the given options that it cannot take. So the correct answer is option number 2.